Alright, so for this video, we're going to start our complex numbers. If you think back to that section where you had to solve the quadratics, it was kind of a review, and it was about 4 questions on that piece of paper. And one of them, you actually ended up with a negative radical, and a lot of you were asking me, hey, there's no solution here. And there is a solution, but it's what we call an imaginary solution, and you had that letter I. And a lot of you, I was telling you, hey, you take off the negative and you add an I before the radical. That is what this entire section and tomorrow's section is going to be like. So, this part here for 1, 2, 3, and 4, I want you to type these in the calculator at home, and you can kind of figure out that, hey, number 1 would be negative 2. Number 2, you end up with no solution, or your calculator says error. Number 3, the calculator would say error. And then number 4, you end up with 2. So the main difference between 2 and 3 is that you have that negative under the radical versus 1 and 4, you have a positive number under the radical. And then if you read my little statement here, the error in your calculator is not a mistake. Your calculator cannot compute complex numbers because technically they are imaginary. So in that case, this is one of those where you're going to have to do everything by hand. But it's not too difficult. There are only 4 different powers of I. So we use the letter I to denote a negative number under a radical. The most simplest number you can think of is 1. So I is equal to the square root of negative 1. And with that being said, I squared, all you're doing is squaring this radical. So if we end up with the square root of negative 1 times the square root of negative 1, well, a radical times a radical cancels itself out. So you actually end up with the square root of negative 1 squared, and now you can really see this power of 2 undoes the radical, so you're just left with a negative 1, which is what was under the radical. Another way to think about it, if you had 3 times 3, simplify it, square root of 3 times the square root of 3, that would equal the square root of 3 quantity squared. Well, the 2 undoes the radical, so you're left with the 3, okay? So it works the same way. So that being said, I cubed, now we can go back up to our powers of I that we already have. So I cubed, you can break that up into I squared times I to the 1. And then if you think about what they're equal to, I squared is now negative 1. So you have negative 1 times I, which is the radical 1, a radical negative 1. But if you're simplifying it in terms of I to the third is just negative I, because negative 1 times I is negative I. And when you get to I to the 4th, there's 2 ways of breaking that up. You can do I squared times I squared, or you could do I cubed times I to the 1. You get the same thing. I'm going to use the I squared because it's a little easier to see. So I squared is just negative 1, and you have 2 of them. So you end up with negative 1 times negative 1, that's going to be a positive 1. I to the 5th, again, there's 2 ways of breaking that up. You could do a 4 and a 1, because that adds up to 5, or you could do a 3 and a 2, that adds up to 5. Let's do the I to the 4th times the I. So I to the 4th is now positive 1, and I is I. Guess what? 1 times I, you're back to where you started. So that's why there are only 4 different powers of I, and it actually keeps rotating. I to the 6th would be negative 1, I to the 7th would be negative I to the 8th, I to the 9th, I to the 10th, and so on and so on. And that is why we can now use this rule over here. So for finding any power of I, because it would get kind of complicated to keep going and going and going, especially when you have powers like 72 and 38. You don't want to count 38 times. So just remember these rules right here. Divide the power by 4 in the calculator. If the number is 0.00, that's equal to 1. If the number in the calculator ends in 0.25, that is I. If it ends in 0.5, that's negative 1. And if it ends in 0.75, that's negative I. And then right here, why do you think we only use these decimals? I want you guys to answer that on your own, and we'll talk about it tomorrow. And then coming down here, I'll do number 1 with you, and then we'll do the rest of the class together. So, for example, I to the 32nd power, if you take 32 divided by 4, well, you can do that in your head, that's just 8. The decimal, though, there is no decimal, it's 8.00. So then if you scroll back up, 0.00 is 1. So I to the 32nd power is going to be 1. And so on and so on. And then if you go to the next page, maybe you want to try these on your own. I kind of have the step-by-step instructions up here. We'll do those tomorrow as well. And then we're going to be identifying complex numbers as imaginary, real complex, or pure imaginary. All right, and that's all I have for you. So I will see you tomorrow.